So, okay, so what you guys are looking at right in the front of you, let me walk you through the system first because this is, guys, this is your third project. You have done, we did the first project was, what is it, 4 500 amp, 240 120 residential project for apartment building. Then we moved into 600 amp, 120 three-phase for a commercial project. And the industrial project that we are working on right now is 4,000 amp, 48277. So you guys are familiar with systems. You should be familiar with systems. So starting from the top, Adam, the first thing you're going to encounter right here is this is typical power system coming to a building. Typical power system coming to a building. Can you guys see? Typically, utilities will give you a delta Y transformer. Can you guys see at the top? This transformer is the utility transformer, Matt, that you put outside, right, in the site, right? That transformer is typically 13,800 volt on the primary and on the secondary 48277. Can you guys see that? Everybody can see that? That big box at the top is the utility transformer, owned and operated and installed by the utilities. Then these little things here, these are supposed to be conduits. Can you guys see that? These are supposed to be conduit. Inside them supposed to be wires. So then from the transformer, which is 13.8 primary, secondary 48277, owned and operated by the utility, you bring the power atom to the termination box. Can you guys see that? It says service point, CT cabinet, meter socket, termination box, right? You guys put them for me, Revit. When we did Revit, we did the same thing. Now, out of the termination box, you bring the power. When I say bring the power, bring conduits and wires from the transformer to the termination box, from the termination box into the first switch gear, the service equipment. The service equipment here is a 4,000 amp, very similar to the service, actually identical to the service equipment, Karen, that we have in our building, 4,000 amp. Inside the service equipment, guys, right here, that's your service equipment. Then you take a feeder. So right here, service equipment. Then you take a feeder right down here. Can you guys see that? To a transformer. This is a delta Y transformer, 75 kVA, 482, 120. That's called separately derived system transformer. This is the receptacle transformer, Adam, the one that we did in math, the receptacle transformer that we're supposed to do for our receptacle panel. And then and then we took a feeder from this transformer directly into a 225 amp, 120 receptacle panel. And the amps are so important, the voltage are so important, because when we do ground and bonding, we're going to take the amps and the voltages and all these things into consideration. So that's a branch circuit going to a transformer to feed a receptacle panel. That's a typical grounding and bonding. The reason why I picked up this scenario for you guys, because that's called separately derived system. We're going to talk about separately derived system. And grounding and bonding for it is unique by the code. Then, Karen, we took another feeder. Can you guys see right next to it, right here? Probably it should be right next to it. Everybody can see that, guys? I have another panel board in the same building. I can't emphasize the word the same building because, Adam, if the panel board is in the same building, grounding and bonding will be unique. So this panel right here, so here's my service. From the service, I took a feeder to feed a transformer that feeds the panel. Then I took another feeder that feed another panel inside the building, and a third feeder to feed another panel inside the second panel, guys. Two panels. One of them is inside the building, and the other one is outside, is a different building. Can you guys see that? So this panel is 1,000 amp, 48277 inside the building. The second one right underneath it, Karen, is a switch port in a different separate building, a 2,000 amp 48277 a separate building. Three feeders, ladies and gentlemen. One of them feed a sub panel and in the same building, the other feed a sub panel in a different building, and the third one feed a transformer that feed a receptacle panel in the same building too. Any comments, guys? Any questions about what we have? That's exactly what you did, right? Isn't that what you guys did with me? Instead of 1,000 amp, didn't you come up with what is it, 800 amp or 600 amp main panel, mechanical panel 1 and mechanical panel 2? That's exactly what equivalent to mechanical panel 1 and mechanical panel 2. All right, right next to it, Karen, I have a generator. This generator is very similar to the generator that you guys have for your project. I have a separate derived system generator. They're called separate derived system. And I want to bring the power here to tie it to the switch gear. Any comments, guys? Any questions about what we have? Everybody understand what we have? Karen, does it make sense? Yes, no? Derek, makes sense? What we have? All these systems. Okay, so these now, you guys should be able to size all these cables. If you don't, I think you should ask me for a refund. Believe, I really mean it. So bringing the cables to the switchgear 4000 amp, what do? You divide it by 10, got your 400 amp, and go size your conductors. Now I want to bring to your attention, guys, since this is grounding and bonding, I want to bring your attention to the numbers. Can I get you guys to look at the numbers? Do you see 1.0 and 2.0 and 4.0? These numbers, the reason why I put these numbers, because right in page 2 and 3, they're identified. So each one of these the green is my focus. The focus right now is to do grounding and bonding at the green. So I want to bring you to your attention, Adam, if you see 1.0 right here. So 1.0, can you guys see that right here? 1.0, it's called grounding conductor. Everybody can see the grounding conductor. And right here, let's go say what grounding conductor is. Grounding conductor, it's at the service equipment. How do you size it? Based on the power system unbalanced load, number 1. Number 2, not smaller than the main bonding jumper. Number 3, if you parallel, you can't go less than 1 aught. And number 4, if you put them in different conduits, you base the conductor, the neutral, based on the conductors in that particular conduit. Matt, does it make sense? This is how you size the neutral at the service. This is how you size the neutral at the service, John. And for those of you who doubt your friend Chad, here's all the references from 2011, Adam, that tells you to do so. Okay? Any comments, guys? Any questions? Everybody can, you can see the connection between 1.0 and go all the way up to this conductor, which is called 1.0. That's the neutral, right? That's the neutral. And why do we talk about the neutral when we're talking about grounded and bonding? Because the neutral is a grounded conductor. It's connected to the ground. Any comments, guys? Any questions? Comments, questions about 1.0? So let's go. So I'm going to walk you guys through the whole system, and then we'll go size it. I have an exercise on that one. So let's talk about the first number 1. Let's start with number 1. So Adam, number 1 is 1.0. This is called the grounded conductor. That's the neutral that comes out of the Y. Can you guys see that gray? Comes out of the Y of the utility transformer and come and tie to the CT cabinet neutral. Remember when we guys went to EMI? Isn't that what you guys saw? That CT cabinet? They tie it to the neutral, and also they bond with that neutral. They bond the box. They are allowed to bond the box with the neutral. And then they bring it into the switchgear, the main panel. Everybody understand the 1.0? It's called grounding conductor. If you guys go right here, 1.0 says grounding conductor, neutral, service equipment. By the way, on the test and the final, this should be with you. Because I don't know if anybody can do the calculation without having the sheet in front of you. It's just so involved. So 1.0 grounding conductor in neutral at the service. And I'm going to talk you, the red atom is an example for you. The sizing, here's what the rules, like I said, based on unbalance, not smaller than the main bonding jumper, not smaller than 1 aught, and based on the conductors in each raceway, if you're paralleling them. And here's all the references. Okay. Before I move about 1.0, can I have thumbs up, Chad? We know what 1.0 is. Yes? Derek, does it make sense? 1.0, it's called the grounding conductor. Karen, does it make sense? Shall we move to 2.0 now? 1.0 is good? Okay. Let's move to 2.0. Can you guys see the 2.0 here? Now we brought the neutral atom. We brought the neutral to the switch here. The second thing you need to do, can you guys see that? I'm going to use a different color here. Right here. Can you guys see that right here? That conductor is number 2. This is called main bonding jumper. So Karen, what you do with the main bonding jumper, you take the neutral and you bond it to the ground. You bond the neutral to the ground and to the enclosure inside the switchgear. That's code requirement. Can I have thumbs up, Chad? We know what a main bonding jumper is. It's 2.0. Can you guys see that wire coming in here? That green wire, it's called main bonding jumper. Main bonding jumper. So that's number 2 is main bonding jumper. We're going to go size it in a second here. So let's go, if you guys go down, Adam, here you go, 2.0. Let's go to 2.0. Here's 2.0. 2.0, ladies and gentlemen, is called main bonding jumper. It bonds the neutral to the ground at the service. How do we size it? We size it based on the service entrance conductor. And if service entrance conductor are parallel, multiply the number of sets by the service entrance conductor size. And if you go, and if you're larger than 100 kcm copper or 1750 aluminum, you have to start use the 12.5%. You guys remember using this? We had an example where we used the 12.5%. And where does this information came from, Karen? It came from 250.28 D1 and table 250.66. Any comments, guys? Any questions about 2.0? Any comments, any questions? Everybody understand what a main bonding jumper is? What's the, you cannot call it bonding jumper, Adam. You have to call it main bonding jumper, right? You can't. You have to name it exactly what the code call it. It bonds the neutral to the ground. Karen, I'm going to walk you guys through sizing it right here in a second. Can you guys see the sizing? Size and example. Okay, so that's my main bonding jumper. Let's keep going, guys, and into the system and just explain what the system is. Then let's go to 3.0. So Derek, my friend, 3.0, can you guys see it right here? 3.0, it's called grounding electrode conductor. Grounding electrode conductor is the conductor that you take from the ground bar in the switch gear directly to the ground rod, concrete encased electrodes, anything metallic in direct contact with Mother Earth. That's called grounding electrode conductor, right in here. So what, do you guys remember when we went to Boston Scientific? You saw that copper bar, right, attached to the, in the electrical room, attached to the wall, and there's all these grounding conductors attached to it. That's what you see right here. So you bring a wire to the ground bar, that ground bar here on the wall, and from the ground bar, you have to go, there's these systems here, what you're looking at, guys, these are called grounding electrode systems. What the heck is a grounding electrode system? Grounding electrode system defined by the NEC code book as metallic object in direct contact with Mother Earth. One of them, ground rod is one of them. Ground ring, water, metallic water, concrete encased electrodes, foundation of the building that has steel in it, that's qualified. Beams, concrete beams, steel beams in direct contact, that's grounding electrode conductor. So all these guys, from the water into the beams, into wire, into a plate, they also have the NEC code book guys define a copper plate with certain dimension. You bury it in the ground, and that will act as your connection to the ground. Can I get you to understand this is grounding bar? You have to tie, the code requires you to tie to only one thing, Adam. Water or concrete if you have, but if you have it. But if you have other things in the building, you have to tie to it. So you end up right here, guys, tying, if your building is concrete, you end up tying to the foundations of that concrete. If it's steel, you end up tying to the steel. And you end up also tying to the water, You end up also tying to the, when we went to Boston Scientific, did you guys see the 500 kcm big, thick conductor ground ring? They call it ground ring, tied to the ground ring. This is what's going to ground and bond your system to the Mother Earth. Can I just get you to understand that 3.0 is the conductor, and each one of these guys, 3.0 here, each one of them would be, first you bring one into the ground bar, and then from the ground bar, Adam, you go to each and every one of these grounding electrode systems. These are grounding electrode systems. Okay, so let's go look at 3.0, shall we? 3.0, gentlemen, 3.0 right here. Okay, so I would like you guys to look at 3.0. 3.0, it's called grounding electrode conductor. If you were to stay in this business, Derek, and you don't know these terms, you will never understand, you really would never. Because they talk about them, people in the field talk about grounding. The terms and the names are very unique and specific. Like, I'm Chad Curdy. That's my unique name, identifies me. The same thing that gentleman here is grounding electrode conductor. Grounding electrode conductor, that's what defines that bit. So, grounding electrode conductor, gentlemen, at the service, look what happens. You size it based on the service entrance conductor, and you have to go to 250.66, like you guys know that. If you are, if the size is, you don't have to go larger than 3 aught. Can you guys see that? 3 aught is the maximum for grounding electroconductor. And minimum of one electrode connection. If others exist, you must tie to it. If you're tying to a rod, a pipe, or a plate, you don't have to go larger than number 6 copper or 4 aluminum. Concrete encased electrode, you don't have to go larger than number 4. Ground ring, not larger than number 2. Any comments, guys? Any questions about grounding electrode conductor? When you have a grounding electrode conductor, you tie it to that plate, copper plate, and then from that copper plate, you can go to a ring. Can you guess? Here's what a rod. If you go to a rod, you don't have to go more than number 6, Adam. If you tie to concrete encased electrodes, a foundation, you don't have to go larger than number 4. If you tie it to a ring, a ground ring around the building, you don't have to tie it. You don't have to go larger than number 2. Any comments? Any questions, gentlemen? Any comments? Any questions? Can I have thumbs up that we know what 3.0 is? 3.0. Everybody on the thread? 3.0. Okay. So now we know what 3.0 is. It says grounding electrode conductor. Let's move on to 4.0, guys. And I'm coming. So that's my grounding electrode conductor with the grounding electrode systems. So Adam, let me see, close that one. So we have 3.0. Now we did grounding and bonding. 4.0. Can you guys, Karen, can you see where 4.0 is? Everybody can see 4.0 is. Can you guys see that wire? Matt, do you see that little wire there? That's called, this 4.0 has a unique name. It's called supply side bonding jumper. Now what the heck is that? Supply side bonding jumper, it takes the conduits, the metallic conduits, Adam, that's coming from the bottom of the switch gear and tie them to the ground bar inside the switch gear. It's called supply side bonding jumper. Now remember, we are at the service. We're at the service. Supply side bonding jumper at the service. Supply side bonding jumper. So if you guys go all the way to 4, here's 4. Can you guys see what 4 is? 4 is called supply side bonding jumper. So Karen, here's 3 conduits coming to the bottom of the switch gear. Can you guys see that? You take a wire, tie the first one to the second, to the third, and to the ground rod, to the ground bar in this switch gear. Or you can home run them. Take one conduit, clamp on it, and tie it to the switch gear, then the second, then the third. 2 options. How do you size the supply side bonding jumper, guys? The supply side bonding jumper is sized exactly as the main bonding jumper. Same as the main bonding jumper. Do you guys see the the terminology that they use? Supply side bonding jumper. When you size it exactly like the same as the main bonding jumper. Identical to the main bonding jumper. Can I have thumbs up, Chad? We know the supply side bonding jumper. So when you become a project manager, guys, that's the thing they're going to be looking at. Your conductors are coming. The inspector will come and say, well, we didn't bond your conductor, your conduits. Now, Karen, if my conduits are PVC, then the supply side bonding jumper shall not exist. Did you guys hear me? If it's PVC, you're not bonding PVC, are you? These are just, if it's EMT or rigid, anything metallic, you have to bond them. Okay, so that's my supply side bonding jumper, gentlemen. Let's go to, so that's, can you guys see that? That's basically the grounding and bonding at the service. The grounding and bonding at the service. Grounding and bonding at the service. Any comments, guys? Any questions? So we walked you guys through number 1, the grounding conductor. Number 2, the main bonding jumper. Number 3, the supply side bonding jumper. Number 4, number 3 is a grounding electrode conductor. Any comments about these 3 things? Any comments about these 3 things? Comments, questions? Comments, questions about these 3 things? Okay, before we move forward, I'm going to go size them, guys. So look how we size them. Apply the rules. I'm going to go apply the rule first for the grounding conductor. Okay, Karen, here's my, to size a grounding conductor, the first thing I have a 4,000 amp switchgear divided by 10 runs. That will give me 400 amp Can you see? I have 400 amp. If you take it to 310.15, 310.15 guys, you take it to 310.15 B16, that will get you a 3 conductors number 600 kcm. So that's how you size the service conductor. This is the 3-phase. These are the 3-phase conductors. You size the 3-phase conductors. First, 10 sets. That's your size, guys. You did that one for me, right? Then, to size the grounded conductor, we take the 10 because we have 10 sets, multiplied by the 600 because each one of them is 600, multiplied by 12 and a half, you get 750. You take the 750 to chapter 9, table 8, and that will get you one conductor, 750 kcm. So your neutral, guys, can be one big fat conductor, 750 kcm. Now, there's one other problem. That's if you're putting him all in one conduit, Adam. Are you putting him in one conduit? No, we're not putting him in one conduit. We're parallel. So when you parallel, you apply this rule. If you guys look at this rule, it says when you parallel, when you size a conductor, take the largest ungrounded conductor, go to table 250.66, and size it based on 250.66, and that will get you 1 ohm. So gentlemen, your neutral conductor cannot be less than 10 sets of 1 ohm. 10 sets of 1 ohm. Any comments, any questions? So that's how we size the neutral conductor. So there are 2 sizes for the neutral conductor. Your neutral conductor, guys, can be 1 conductor 750 or 10 conductors 1 ohm each. Or 10 conductors 1 ohm each. So I have 10 conduits, Adam and Derek, and each conduit has 3 conductors 600 kcm and 1 conductor 1 ohm for the neutral. Any comments, guys? Any questions about the neutral? 4.5%, which is 0.125. That's 12.5%, directly from the code. That will be right in here. When you size, if your service conductor, guys, are more than 1100 kcm, here, if your service conductor are more than 1100 kcm, then you start multiplying 12.5% by the size of the conductors, the service conductor that you have. Any comments, any questions, guys, about the grounded conductor? The grounded conductor. Like I said, you guys have 2 homeworks to do directly based on that one. So please make sure you do that one. So okay, so that's my grounded conductor. Let's go to the second thing, guys, was the main bonding jumper. I want to remind you guys, the main bonding jumper, this is how we size the main bonding jumper, right here. The main bonding jumper, everybody can see that? The main bonding jumper is sized based on this. So the second thing that we did is number 2, main bonding jumper. If you guys go to the main bonding jumper, Adam, right in here. Here's my main bonding jumper. My main bonding jumper, gentlemen. Here's my main bonding jumper. Here's my 4,000 amp switch gear divided by 10 parallel. Get you 400, go to 310.15 B16. That will get you 10 sets of 3 conductors, 600 kcm. If you guys don't know how to size these, ask me for a refund. I'm not kidding you. You know, because this is your 3rd project. If you don't know how to take an amp to 310.15 B16 and size a conductor, you know, we didn't do you a favor. So 310.16 under 75-degree column, so it says. Then you take the 10, multiply it by 600 kcm, multiply by 12.5%, give you the 750. You take the 750, guys, to chapter 9, table 8, and that will get you that main bonding jumper. The main bonding jumper will be 750. Main bonding jumper will be 750. Any comments, guys? Any questions about sizing the main bonding jumper? The main bonding jumper at the service. Main bonding jumper. Main bonding jumper. Okay, so the 3rd thing that we need to do, guys, is I'm going to go directly into number 3, guys. Do you see number 3 is 3.0, the grounding electrode conductor. So Derek, my friend, the grounding electrode conductor, very easy, very simple. The grounding electrode conductor, you take the number of sets multiplied by the size, give you 6,000, take it to table 250.66, give you 3 ohm maximum. So that grounding electrode conductor does not need to be more than 3 ohm. No need to go larger than 3 aught. Now, the ground, the grounding electrode conductor that going to the rod, the one that's going to the rod does not have to be more than number 6. To the pipe, not more than number 6. To the plate, not more than number 6. To the concreting case electrode, not more than number 4. And to the ground ring, not more than number 2. You can see that? These are always typical, not more. Now, can you put them bigger than that? Bring it on, but not more than that. And here's all the definitions that we talked about, guys, all the sizing for grounding electrode conductor and the references. Any comments, gentlemen? Any questions about the grounding electrode conductor? Comments, questions about grounding electrode conductor? System bonding jumper. If you guys go to the system bonding jumper, it's 4.0. System bonding jumper, bonding the conduits. Can you guys see that? So, Adam, when you go to 4.0 right here, very simple, very easy. If you guys go to the same switch gear, 4,000 amp switch gear that you guys are having here, and look what this will tell you. 4.0, guys, very easy. Can you guys see how to size it? It says main bonding jumper. So it says size it the same as the main bonding jumper. Any comments, guys? Any questions? Size it the same as the main bonding jumper. So it's 750. Any comments, any questions about 1.0, 2.0, 3.0, and 4.0? Grounded conductor, main bonding jumper, supply side bonding jumper, and grounding electrode conductor. These are the fundamental building blocks of the grounding and bonding system at the service. They call it grounding and bonding at the service. Before I leave that topic and move to a different topic, guys, any comments, any questions about bonding at the service? So, Derek, my friend, you are right here. They call it, the ND sequence will call it bonding at the service. Can you guys see all the stuff that I just talked about was right here at the service. Bonding and grounding at the service. 4 things. Supply side bonding jump, main bonding jumper, grounded conductor, main bonding jumper, grounding electrode conductor, and supply side bonding jumper. 4 things you have to do at the service. Any comment before I leave the service box? The service box, guys, here's your service. Can you see that switch gear right here? That's all the stuff that's going right inside the switch gear. Right inside the switch gear. Now I'm going to move away from the switch gear and go to some panels here. Can you see that? I'm going to move away from the switch gear and go to the mechanical panel. Any comments, any questions about grounding and bonding at the service? Grounding and bonding at the service. 4 things. Okay, now, can you guys, so we're done here. We're done at the service. Done. 4 things. I'm going to go and do grounding and bonding at a sub panel. Can you guys see that? At the sub panel, right here. So I'm going to move away to an equipment, guys, and go grounding and bonding at a sub panel. I'm going to choose 2 things then. I'm going to choose, first, this is equivalent to my mechanical panel. Here's my sub panel. Can you guys see that right in here? Now, this is a sub panel. That could be a 200 amp sub panel here. The example that I'm giving you guys, it's a 1000 amp 48277 sub panel. Can you guys see that? I need to size, in terms of grounding, the following. I need to size the grounded conductor that's coming from this switch gear here. So it's coming from the switch gear to this switchboard, or switch gear to this panel board. And I need to also size the number 6. Can you guys see number 6 and number 7? Number 6, Karen, is called the equipment grounding conductor. That's the wire that comes from the fixture to that panel. It's called the equipment grounding conductor. The terminology, guys, is so important, because if you don't know this terminology, you will never understand grounding and bonding. Equipment grounding conductor. And then that little connection here, guys, can you guys see that little connection connecting bonding the conduit? They call it bonding the conduit. That's called equipment bonding jumper load side. Equipment bonding jumper load side. So I have 7 equipment bonding load side and 6 equipment grounded conductor, and 1.2 is the grounded conductor. So let's go size these. Now this is sub panel. Everybody can see that this is the sub panel. We have a sub panel right here, right? Makes sense? All right. So let's do grounding and bonding on a sub panel. Grounding and bonding on a sub panel. So Adam, this is equivalent to this guy here is equivalent to being done with the switch gear, the first panel. This one here This guy here is equivalent to bonding right here at this panel. All right, so I'm going to take, first I'm going to size 1.2. So let's go size 1.2, guys, right here. 1.2, 1.2, it's called, right here, guys, it's called grounded conductor at the sub-panel. Okay, I have a 2000 amp Karen. How do you size feeders for 2000 amp? You guys know, right? You parallel, right? You parallel. So I decided to parallel 5 sets, Derek. Divide by 5, get you 500, right? 400. Take the 400 to 310 or 15 B16. That will get you 3 conductors, 600 KCM. Can you guys see that? Then you can do the same thing as 5 times 600 times 12.5%, give you 375. Take this one to table 4. That will give you either your neutral can be, guys, 400 KCM, or if you go by, you parallel them in different conduits, you take the 600 KCM to 250, that's 66, that will get you minimum of 1 knot. Any comments, any questions? Any comments, any questions? So that would be 5 conductors, each one of them is 1 knot. All this coming from grounding and bonding references. Any comments, guys? Any questions about sizing the neutral at the sub panel? You guys, when I give you an example, would you be able to do? I'm going to change it right now. Change this one. My homework is changing that number here into 1000 and do the same steps. Any comments, gentlemen? Any questions? Comments, questions? So that's your grounded conductor at the second panel or the sub panel. Now there's that calculation. Now let's go, guys, into let's go into number 6 and number 7. Can you guys see number 6 and number 7? Now, Adam, if your conduit is EMT conduit, your conduit will be your equipment grounding conductor. Did you guys hear me? If your conduit is an EMT conduit, your conduit will be your equipment grounding conductor. If it's rigid, it will be an equipment grounding conductor. No need for conductor. If your conduit here is PVC, then you have to pull an equipment grounding conductor with it. Okay? When you pull it, then you have to an equipment grounding conductor with it. If it's an EMT conduit, guys, you also have to pull an equipment grounding conductor, and you need to bond the conduit. So do me a favor. Let's go to 6 and 7, will you? So if you guys go to number 6, right here. Number 6, Karen, it says equipment grounded conductor. How do you size it? You take 2000 amp, take it to 250.122, and that will get you 1 conductor, 250 KCM. 1 conductor, 250 KCM in each and every one of these conduits. Does it make sense? No? So that's how you size the 2000 amp equipment conductor. So there will be 10 of these. There will be 10. 5. There will be 5, 1 in each one of these conduits. Here's 1, 2, 3, 4, 5 conduits. All these are different conduits. And you will be pulling, gentlemen, 1, 2, 3, 4, 5 conductors for in each and every one of these conduits. Any comments, any questions, guys, about the equipment grounding conductor? Make sense? Cool. So right underneath it, guys, it's called equipment bonding jumper load side. That's kind of a weird term. This is when they bond the conduit to the switch gear. It could be the same cable. So Karen, the way they do them, excuse me. Number 7, the same size. Can you guys see it's the same as an equipment grounding conductor? Everybody can see that? So I made it easier for you. So when you have an equipment bonding jumper, it's the same as an equipment grounding conductor. So what does that mean, though? Here's 2 conduits, guys, coming to the second panel. And the conduits are coming from the bottom. You take a wire from conduit 1 to conduit 2 to the ground bar inside the sub panel. These are called equipment bonding jumper load side. Any comments, any questions about equipment bonding jumper load side? Karen? Yes? Makes sense? No? Derek? Equipment bonding jumper load side? Exactly. You size it as the equipment grounding conductor. What does it mean? When you bring these conduits here, here's the plan. You bring in the conduit from the top to the bottom. You have to bond the conduit to the box with a wire or with a lock nut or what's not. That's called equipment bonding jumper. Okay, so gentlemen, just to summarize, and this is what we have done. We did at the service, grounding and bonding at the service. We did grounding and bonding at a second sub panel. Now, Karen, so this is, I'm going to call this is number 1. This is number 2. Any question, guys, about grounding and bonding at a sub panel? Derek, for the test and the final, this sheet is going to be in front of you. If it's a sub panel, here's the rules. Believe me, it is confusing. If you're not confused, you're not with us. Really. It is confusing. This is what you're going to have in front of you. Chad, when you tell me it's a sub panel, what the heck did Chad say? He said it's called 1.2 and 1. I'm going to go to 1.2 and size exactly based on 1.2. Does that make sense? All right. So I did size 1 and 2, guys. I want to go to number 3, gentlemen. Number 3, Karen, is right here. It's another sub panel. I'm going to call this is sizing the third thing I'm going to do. So this is number 3. Can you guys see that? Now, Matt and Adam, I took a feeder from here and to the parking lot. There's a structure there at another building, a feeder from this building to feed another building. Did you guys hear me? That's why it's unique. So we took a feeder from this building to feed another building, separate, stand-alone building. And we need to do grounding and bonding at the second building. Okay, so Adam, the second building is 2000 amp. The second building is 2000 amp. Oops, is that the separate building? Yeah, the second building is 2000 amp. We need to size the grounded conductor for it. Oh, I thought that was 2000 amp. Never mind. 1.2, the same thing, the grounded conductor. And we need to size the equipment grounded conductor, and we need to size the equipment bonding jumper. 3 things. 1, 2, 3. Okay, and the fourth thing, guys, is grounding electrode conductor. So what they want you to do, Karen, when you go to the second building, you have to have establish a grounding electrode system. Meaning the second building, it's going to have water, so you have to bond to the water. Can you guys see that? You need to bond to the water. You need to you could have also a plate, a ring, concrete encased electrodes, ground rods. So you do the grounding electrode system exactly like you do at the service. Can I get you guys to understand? Can you guys see that little here? So you have to create a grounding electrode system. What the heck is that? A bunch of ground rods in the ground and you tie to them. Or the foundation of the second building, if it's concrete or steel, you have to tie to it, right? The water coming to the second building, you have to tie to it. Exactly, Adam, like we do at the service. Exactly like we do at the service. We do it at the second building. Okay? Shall we go size these 3 for the separate building, guys? The separate building? All right, so the separate building, my friends. Now, let's go to 1.2, and the same thing for the separate building. I was actually... Okay, so let's go to the 1.2. 1.2 is right here, gentlemen. Actually, we were looking at it before. For 1.2, here's the grounding conductor for 1.2, guys. Besides that one, exactly, and we came up with 400. Either one conductor 400 or 5 sets. 5 sets, why not? That's exactly what we're looking at before. So that's how you size the grounding conductor at the second building. If we go to what is it? So let's go to number 6, the equipment grounding conductor of the second building. So Karen, the equipment grounding conductor of the second building, I actually was looking at it accidentally. At the second building, here's how we size it based on 2000 amp. At the same building, which I should have been talking about this one before, at the same building, 2 up. Can you guys see that? The equipment grounding conductor for the sub panel in the same building, it should have been 2 watt actually. And the second building is 250. So you take the 200 amp, take it to 250.122, and you size your equipment grounding conductor. Equipment bonding jumper, guys, identical to the equipment grounding conductor. So for the 2000 amp, 250. For the 1000 amp, 1 up. For the 2000 amp, identical. So equipment grounding conductor load side and equipment grounding conductor and equipment bonding jumper load side are identical, the same thing. Any comments, guys? Any questions about grounding and bonding at a separate building? Really not a whole lot to it when you follow the rules and regulations for it. So summarize. Here's my third thing that I'm going to do. I size the grounding conductor. I size the equipment grounding conductor. I size the main bonding jumper, and I size the grounding electrode conductor. The grounding electrode conductor mat 3.2. Let's go to 3.2. So if you guys go to 3.2 right in here, here's my 3.2. 3.2, gentlemen, has a size exactly like any equipment grounding conductor based on the feeders. For the second building, we size it based on the feeders. Can you guys see that? Based on the feeders, you have to multiply by the sets if you have them. You don't have to go larger than these two numbers. And you have to have at least minimum one grounding electrode conductor, but if other exists, you have to bond to them. So take this. We size the conductors like we did, and we do the calculation like we did. Then you take the 300 kcm to this table, and that will get you maximum, which is 3 aught. So at the second building, Karen, we also have to use a 3 aught to tie to the ground bar. Now tying to the ground rod, you don't have to go larger than number 6. Any comments, guys? Any questions about grounding and bonding at the second building? Grounding and bonding at the second building, right here. Grounding and bonding at the second building. So this is number 3. So Adam, if you have a project and you have a second building, the first thing you want to ask yourself and ask your project manager, I need to establish grounding electrode system here. What does that mean? I need a copper bar right in the electrical room, and I need to take a wire to the plate, a wire to the ground ring, a wire to the steel, a wire to the water, a wire to the foundation concrete encased electrodes. All these are called electrodes. You know, steel of a building, foundation of the building, ground ring, ground rod, water, what else, Adam? A tank. If you have a big tank in underground, metallic tank, you can tie to it. You cannot tie to the gas line. Gas line is unacceptable underground. Any comments, guys? Grounding and bonding at the second building? Any comments, any questions about grounding and bonding at the second building? Karen, does it make sense? Yes, no? Okay. You guys need a few minutes break. I have 2 more things to go over. A generator and a transformer. I can go over them or I can give you 5 minutes break. What do you think? 5 minutes? Okay. 2 more things. I need to do a generator and I need to do a transformer. Okay. These called separate derived systems. Let's take 5 minutes. Go. So before I go ahead and start, any comments, my friends? I'm going to shrink it a little bit. Any comments, any questions? Comments, questions? Trying to fit all of them. Adam, does it make sense? No, yes? So just to summarize, guys, what I've done with you is we did grounding and bonding right at the surface, number 1. Then number 2 at a sub-panel in the same building. Number 3 at the sub-panel in a different building. And I need to do number 4. Number 4, guys, is grounding and bonding at a transformer. Number 4, which is grounding and bonding at a transformer that feeds a panel that we own and operate. That's called separate derived system. And number 5 is grounding and bonding at a generator, separately derived system or non-separate derived system generator. So I'm going to go over 4 and 5. Any comments, gentlemen? Any questions? Comments, questions? So let's go to, I'm going to start with number 4, Adam, at the generator. So let's go ahead and expand this one a little bit so we can see what we're doing. Okay, I'm going to go walk you guys through this, if you don't mind me. Derek, my friend, here's what happened. We need to go right from the switch gear. Look what happened. From the switch gear, can you guys see that? From my switch gear, I brought the feeder through conduits to a panel. With that feeder, you have to have something called 7.0, Adam. 7.0, that's an equipment grounding conductor between that switch gear and the transformer. That's called equipment grounding conductor. Very simple, right? Okay, so we have an equivalent ground conductor right here. That's first thing I'm gonna size, the equivalent ground conductor, okay? Um, and right with it, we bond the conduits from both sides. Can you guys see that, how we bond the conduits from both sides if they're metallic? If they're non-metallic, then you just pull the equivalent ground conductor inside the conduit and move on. That's the first thing you do to the transformer. Okay, the second thing you need to do is right at the transformer, you have to have a grounding electrode conductor. A grounding electrode conductor. That's this guy, guys. A grounding electrode conductor from the transformer all the way to the grounding electrode system. Guys, transformers, almost all of them are called separately derived system. The reason why they call them separately derived system here, this is called separately derived system, because can you guys see the delta? Everybody can see the delta here. Maybe this is not a good choice. The delta and the Y are completely separated from each other. Matt, does it make sense? Look at the delta wires and the Y wires. Do you see any connection between the delta, the wires coming to the delta, to the 480 here, and the wires coming to the 208/120 side? Is there any connection? None, except through the ground, which is okay. If there is no connection between the primary and secondary transformer, the NEC code book guys call this a separately derived system. You're going to hear the word separately derived system. So how do we ground and bond the separately derived system? Do you understand what a separately derived system is? No connection whatsoever between the primary conductor to the transformer and the secondary conductor to the transformer, except Anna, through the grounding wires that they don't count. Phases and neutrals are completely isolated. Do you see the neutral coming out and the phases here and in here? Completely isolated from each other. That's called separately derived system. Okay, when you are in the separately derived system, gentlemen, which you are right now, you have to do, let me zoom a little bit. When you are at the separately derived system, I'm going to go all the way here. It's called separately derived system, no connection between the primary and the secondary. The first thing you need to do, Adam, is bring a grounding electrode conductor, which is that guy right in here, and take it to the ground bars right in here, to the grounding electrode system. Okay, that's must by code. Then the second thing that you need to do, that's the first thing. The second thing is you need to have this guy. 5, it's called system bonding jumper. Can you guys see that right here? The system bonding jumper that bond the new neutral that you created. Derek, you just created new neutral for the 28120. You are to bond the neutral that you created for the 120 to the grounding electrode system inside the transformer. Can you guys see that? That's exactly like the system bonding jumper, except it's inside the transformer. This number 5 is called system bonding jumper. It's not main bonding jumper. It's system bonding jumper. Okay, so that's number 5. Number 6, of course, you have to, or another thing you have to do is the neutral. You have to create a neutral. Then you have to have something called 4.0. 4.0, this is called supply side bonding jumper at the separately derived system. Supply side bonding jumper at the separately derived system. Okay, so that's what we're going to go, guys, at size and talk about one more time. I'm going to summarize them. The first thing when you have a transformer you need to do, so basically the first thing really is what we call number 5. Bond the neutral to the ground. You have to size the new neutral. Then you have to bond the conduit, bond the transformer enclosure. Can you guys see that? Number 4, supply side bonding jumper, bond the transformer enclosure to the panel. That's number 4. Number 5, my friend, would be, so 1, 2, 3. So we need to also bring an equivalent grounding conductor and bonding jumper load side. These are the 5 things. I'm going to get rid of this one here so it doesn't confuse us. Okay, so I need 1, 2, 3, 4, 5, okay, 6 right here. 6 things I need to go size them for the separately derived system. And I want to remind you guys, my concern is right in here. I'm just concerned about this. This is my concern. I'm looking at this section. Any comments, guys, about the separately derived system? Summarize. Separately derived system is a transformer, delta primary, Y secondary, complete isolation between the primary and the secondary conductors, the phases, and the neutral. When you have a transformer, you are to bond the new neutral that you created to the ground inside the transformer. Then you have to take a wire from the ground bar inside the transformer to the grounding electrode system up there. That's 3.1, grounding your third conductor. This bonding the neutral to the ground in the transformer is called system bonding jumper. You are to create a new conductor that's called new neutral conductor. It's a white to go with the 208. That's a 208 neutral. Other than this neutral, guys, right here was a 480 neutral. This is a 28 neutral. Okay, that's number 5. And number 1.0. Then we have to do a supply side bonding jumper, which is typically for you guys, have you noticed when we were looking at transformers yesterday, they have a flex, they flex them, right? They have a flexible metallic conduit, tie the panel to the transformer. Inside that flex, they pull a wire. That wire that they pull to ground to tie the transformer to the panel, ground bonded together. That wire is called supply side bonding jumper. You're looking at it right here. And from one end, they tie it to the inside the conduit, then they tie it with a grounding bushing. They tie it to one end inside the switchgear and to the other end inside the transformer and to the other end inside the panel. So you have bushings, guys, grounding bushings inside the panels that they lube it. The way they do them, they bring the wire, lube it. They don't cut it. They lube it. They put it under a lug, tighten it, go through the conduit, then when they enter the second enclosure, they put it under another lug, tighten it to bond the conduit, and all the way to the ground bar inside the panel. Any comments, guys? Any questions about bonding and grounding of the separate drive system? Can you guys see any connection between the ground and the neutral inside the panel here? No. They only bond them right through, either you bond them in the transformer or in the panel, typically inside the transformer. So you are not allowed to bond the ground and the neutral again inside the panel. So separate drive system, you bond the neutral once. You bond it typically inside the transformer. Can I bond it inside the panel? Yes, but you have to go and get rid of this little wire here. You have to remove that wire. Typically what we do, guys, the industry standard is inside the transformer. If you open it, you'll see a bond. You have to go install a bonding wire between the neutral bar and the ground bar inside the transformer. Okay, any comments, guys? Any questions about these things that I want to go try to kind of focus on sizing these ones for the separate drive system. So I want to focus on this and this and this and this and this, basically, right? And this one. So these are the ones I'm going to go size for the separate drive system. Any comments, any questions? This would be the receptacle panel that you guys have. Karen, also this would be the 28120 transformer. Remember the 28120 transformer that we have for the 28120 bus duct? Am I the only one who's excited? I get excited about grounding and bonding. You'll be surprised, guys, how many Masters and Germans, they wouldn't know what you will know if you follow this. I'm not kidding you. This is, if it's complicated, it is complicated. You take it to the next level. You become a project. If you're a designer, Adam, and you're laying out receptacle, nobody will ever ask you about this. You can live all your life without knowing it. And you can be a great designer too. You know what I mean? You become a project manager. You're in the field for Parson and Hunt. And you're working in the field with your electrician. And whatever they do is your responsibility. These are the things that you're going to, or you're designing the system to a higher level designer. These are the things little things that catch you and kick you in the butt if you don't pay attention to it, right? These little things, you don't worry about them. You don't know about supply side bonding jumper. You know, you worry about the main feeders. These are the little things that bring you to the next level. Does that make sense? The little things that bring you to the next level. Okay, so let's go guys size it, shall we? I'm going to go size these 1, 2, 3, 4, 5, 6 things for that panel. Let's start with 1.1. Can you guys see that? 1.1. I will start with 1.1, gentlemen, and walk my way through it. So here's my 1.1. 1.1 is a neutral. So I'm going to go down right here. Here's 1.1, Adam. My 1.1 is, remember, it's a neutral. So for the transformer, I'm going to focus, here's my 1.1, it's grounded conductor, with a term that code uses grounded conductor, which is a neutral, at the transformer. So the way you need to do, first you need to size the ungrounded conductor. I have a 225 amp panel. You guys remember that panel right underneath here? I need to go size, basically my panel is 225 amp panel. I need to size the ungrounded conductor for it. Okay, where am I here? Okay, so I need to size for 225 amp panel. So that's easy, Adam. You take the 225 amp panel to 310 you got your 4 amp. Done. Now, I need to size the grounded conductor. The NEC code book, guys, says it cannot be smaller than the system bonding jumper. It can't be less than 1 amp if you're paralleling. If you're paralleling in different raceways, it has to be sized based on that raceways. We're not paralleling here. So you take the 4 amp, guys. Can you see that? You take the 4 amp to table 250-66, get your number 2. Okay? The minimum grounded conductor that you can do for this system is 1 conductor number 2. That's the bare minimum. 1 conductor number 2. Now, Adam, if you load these harmonics, heavy harmonics, they overload the neutral at the panel, 225 amp panel. A lot of engineers, guys, go full neutral. Can you guys see that? So you have 2 choices. Either you go full neutral, a lot of engineers on this go full neutral. Okay, here's my full neutral. Full neutral, that's right here. They made the grounded conductor like we did in our project. I told you guys if it's close to 200 amp or less, full neutral. You can pull full neutral, or you can go to the bare minimum that the code allows you to, which is number 2. So what's the answer, Chad? You're going to write me these 2. So if the panel is 225, guys, full neutral. But what's the bare minimum though? The bare minimum is number 2. That's your grounded conductor for the transformer. The grounded conductor for the transformer right here. Okay, so let's go to, so that's number, which number is that? That's number 1. Now, Adam, I'm going to go to number 5. Can you guys see number 5? That's called connecting the neutral to the ground inside the transformer. Okay, let's go all the way to number 5, shall we, please? All the way to number 5. Number 5, Karen, is called the NEC code book, not me. The code calls it system bonding jumper. Not main, system bonding jumper, identical to the main bonding jumper at the service. You bond the neutral to the ground inside the transformer, guys. You bond the neutral to the ground inside the transformer. That's what you do. Okay, how do you size this? Well, very easy. The way you size it, here's the size that I'm going to be looking at for the transformer. Can you guys see that? You go to the panel, 225 amp, size the ungrounded conductor, piece of cake, then take the 4 amp, 250, then the main bonding jumper is 2 amp, is number 2. Now, if you parallel, remember, we're not paralleling here. If you parallel, then you have to apply this rule and this rule, which is feeders are parallel, multiply the number of sets by the feeder, like at the service. And if you go higher than these 2 numbers, then you have to apply the 12.5%. Then you have to apply the 12.5%. Now, if you're like Derek doesn't believe until he sees, then you have to go review these, read them, understand them, and it will tell you the same thing. Does that make sense? I always like Derek to, especially when I do training for electricians and engineers who question me more than you guys do, I always like to reference these. Because, well, where did you get this, Chad? I mean, I could have, right? These are interpretation of Article 250, guys. There's all the information. All the references that tells you to do this way. Does that make sense? Try to make it easier for you. You have to dig through 100 and some pages to get this sheet in the NEC code book. Okay, so that's the system bonding jumper. Any question, guys, about the system bonding jumper? That's how you bond Adam the neutral of the 120 to the ground inside the transformer. With a one conductor number 2. One conductor number 2, system bonding jumper. All right, so we did 2 things, gentlemen and ladies. We did, so I want to remind you quick, so we're walking through this. So here's what I did. I sized the neutral, and I sized also the system bonding jumper. So Adam, I'm going to go size the supply side bonding jumper. Can you guys see that? Everybody can see 4.1. That's called supply side bonding jumper. A wire, inside the conduit, the flexible, tie the switch key, the transformer enclosure to the panel enclosure. Okay, so 4.1. Let's go to 4.1, shall we? Very easy, guys. Here's 4.1. 4.1, can you guys see no calculation needed? It tells you, hey, by the way, it's called supply side bonding jumper. Oops, I'm sorry, 4.1, right underneath it. 4.1, it's called supply side bonding jumper at the symmetry system. It's number 2, and it's identical to the system bonding jumper. Don't do any calculation. Size it the same as a system bonding jumper. If you don't believe Chad, you're going to go dig into these articles and sections, and that will tell you the same thing that I'm telling you. So the supply side bonding jumper and the system bonding jumper are identical. Okay, so that's 4.1, gentlemen. Any comments? Derek, does it make sense? 4.1, the supply side bonding jumper? Good. Okay, so I sized 1.1, 5.0, 4.1. Now I'm going to go up and I'm going to size these two things. I'm going to go size, guys, number one, 3.1. Can you guys see 3.1 right here? 3.1 is the, what is it? What is 3.1? That's going from the transformer all the way to the grounding electrode system. Let's go to 3.1, shall we? 3.1, Adam, my friend, and Derek, and Matt, and Karen, as 3.1 is right in here. This is what I'm going to focus on, right in here. Okay, so this is called grounding electrode conductor, guys. How do you size a grounding electrode conductor? Exactly like any others. At the separately derived system, based on the feeders, not small, not larger than, does not need to go larger than these two numbers, exactly like at the service. You have to tie it to at least one grounding electrode water pipe or structured steel of a building. If you parallel, you have to multiply the sets like at the service. So 225 amp, guys, take it to 230.15p 16. You get yourself 4-aught. Can you guys see that? It's 4-aught that you got. From the 4-aught, take this one to 250.66, and your grounding electrode conductor size is number 2. Exactly like the supply side bonding jumper and the system bonding jumper. They're identical to a limit. When you start exceeding 1100 kcm, they start getting different. So it's identical, gentlemen, to the supply side bonding jumper and the system bonding jumper. Any comments, guys, about the grounding electrode conductor at the separately derived system? Karen, the supply grounding electrode conductor at the separately derived system. That's called grounding electrode conductor at separately derived system. All right, so let's go to the last thing, guys, which is 7.0. I don't know if we sized that one. 7.0, can you guys see that? And this is 7.0 here and here, 7.0 and 6.0. That's equipment grounding conductor. Did I size it? I did not. Okay, no, I did. So let's go to, so 7.0, guys, and 6.0. Here we go, right here. So this is what I'm going to try to size right in here. Can you guys see that? This is at the transformer. So take the, this is the current of the primary of the transformer. You have to, now we're coming to the primary. This is called the equipment grounding conductor. The cable that you guys are bringing from here, you see that one? Here's the transformer. The cable that you bring from here to the transformer has to have an equipment grounding conductor with it. On the primary side, that's what I'm sizing. So on the primary side, you need the primary conductor current. So take the 75 kVA divided by the voltage, get you 90.2, multiply by 1.25. That'll get you a 12.8. If you go to 240.6, that will get you an overcurrent protection device maximum of 120. You take that 120, guys, to table 250.22, and that will get you number 6. So your equipment grounding conductor, Karen, and your equipment bonding jumper at the load side, can you just see that, is not smaller than number 6. Cover in this case. Any comments, guys, about the equipment grounding conductor coming to the transformer? The equipment grounding conductor coming to the transformer. Any comments, any questions? So that equipment bonding jumper on the load side and the equipment grounding conductor, they're identical. They're identical. Karen, you shall not, any one of you guys, understand it without looking at the diagram. You have to look at where the conductors are coming. And you have to use the same naming. That's what the code uses to name these things. Okay? So let me summarize, guys, and before I go to the generator. So at the separately derived system transformer, they call it transformer separately derived system, gentlemen and ladies, separately derived system, which starts right here. I'm going to go right in here. Okay, here it goes. And all the way separately derived system. Separately derived system. Okay, can you guys see that? That's what I'm sizing. Right here, what I sized, guys, is first I sized that neutral right here. Then we size, this is called the neutral, the grounding conductor. Then the system bonding jumper, Then I size the grounding electrode conductor at the semi-derived system. Then the equipment grounding conductor coming to the primary. And then the equipment bonding jumper both sides. That's where you bond the conduit. Can you see that? You bond the conduits on both sides here. And then the last thing we did is supply side bonding jumper at the semi-derived system. Supply side bonding jumper at the semi-derived system. Any comments, any questions? You guys have gone through, we have a book that called Source book that we teach 24, 20 chapters. You've gone through probably 16 of them in an hour and a half with me. 16, literally 16 chapters. All this information in 3 pages. So when we do training on bonding, we do 16 hours of that, 16 hours for grounding and bonding. Not on this sheet, we do a lot of other details. Okay, the last thing, do you guys still have energy for one more thing? The last thing I want to do, so this is the transformer. We're done here, transformer panel tied together. The last thing I want to do, guys, is generator. Did you guys have 2 generators sitting right here? We have 2 generators sitting outside here. We need to do ground and bonding at the generator. Can I have thumbs up, Chad? Good with the transformers? We know where they are located at least. We might not memorize and understand everything, but we know how to follow the sheet that you gave us, right? Is that good enough? On the test, you grab your sheet and you follow it. If you're in doubt with the name of the conductor, look at the sheet. Where the conductors are located is very important, where they're coming. That's how you put them in a conduit. All right, last thing. You're going to see this, Chad, you still continue to see last thing. The last thing I'm going to talk about, guys, is generator. Now, generators, now let's go, here's my second and last thing I want to talk about, right in here, gentlemen. Generators. Generator atom, you can run them separately derived system or non-separately derived system. What the heck is that, Chad? If you switch the neutral of a generator, remember, generator is a source of power. If you switch the neutral when you tie it to your power system, then this is called separately derived system. If you don't switch the neutral, then it's called a non-separately derived system. Either separately derived system or non-separately derived system. For the calculation I'm going to do right now here, guys, it doesn't really matter if it's separately derived system or non-separately derived system. I'm going to size the following. I'm assuming it's separately derived system. On my system, I have 1250 kW, 48277 generator. The voltage is 48277, exactly like the one that you guys have. I need to size the following. I need to size, number 1, the system bonding jumper. 5.0, guys, it's also called system bonding jumper. So Karen, for separately derived system transformer, we go right inside the, generator. We go inside the generator and we bond the neutral to the ground. Then we have to take a grounding electrode conductor, guys, to the grounding electrode system in the building. Then you have to take something called 4.2, which is supply side bonding jumper. Supply side bonding jumper may take you from the generator to the first disconnect or the first overconduction device. That's called supply side bonding jumper. The last thing you need to do, of course, or one of the things you need to do is find the neutral. Size the neutral. Can I get you guys enough energy to size these 4 things? Do you have enough energy to size them? I have a generator. I need to size the neutral for the generator. I need to size the supply side bonding jumper for the generator, the system bonding jumper for the generator, and the grounding electrode conductor for the generator. Any comments, any questions before we move into the sizing? Comments, questions, gentlemen, ladies? Okay, now remember, this is a separately derived system. Now, Adam, if that was not a separately derived system, look what happened. The only thing that's going to be different here, if that was not a separately derived system, do you guys see that connection here? That number 5 is gone. Number 5 is gone. If it's a non-separately derived system. If it's not a separately derived system, we just don't tie the neutral to the ground inside the generator. Okay, that's it. Number 5 is gone. Everything we calculate stays the same. But number 5 is gone. Now, okay, we have a separately derived system. We decided to switch the neutral. Then, let's go size 1.1, shall we? So I want you guys to follow up with your friend. I'm going to go number one, size 1.1. Can you see that 1.1 here? That's the neutral for the generator. Okay. All right. So the 1.1, gentlemen, the neutral for the generator, and it's right in here. Okay. I'm going to highlight it right in here. Okay. Can you guys see that? To size the neutral for the generator, I need to size the ungrounded conductor first. Okay, go ahead. So I have generator ungrounded conductor. I have 250 kW divided by 1.73480. What's the 0.8? Power factor. Divide, assuming power factor 0.8. Find the amps of the generator. You got yourself, guys, this amount of amps. 1882 amps. That's a big boy. Since it's a big boy, guys, since it's in the thousands of amps, we don't multiply by 1.25 because we assume the overcome protection device are 100% rated, like these ones, 100% rated circuit breakers. So we take the 1882, take it to 240.6, give you an overcome protection device of 200 amp, 2000 amp. If that was a baby generator, Karen, if it was a baby generator, you know what you add here? You just multiply this one by 1.25, assuming it's continuous one. If it was a smaller generator, 500 50 kW. This is a big generator, big amps. These are power circuit breaker, guys, electronic circuit breakers. So it will be 100% rated circuit breakers. Okay, so I have a 200 amp. So what I did, the first thing, guys, is I have an overcome protection device is 200 amp. Okay, then that's it. That's all what I need, guys, to size my conductors. Then you take the 2000 amp circuit breaker, divide it by 5, get you 400. We already sized this one. That will get you 5 sets of 3 conductors, 600 kcm. We've just sized this. Okay, go down again. Grounded conductor have to be sized based on not smaller than a side-by-side bonding jumper, not smaller than 1 aught. At the service, the same thing. Here's my multiplication, exactly like we did the service. You take this number, guys, to chapter 9, table 8, and that will get you 1 conductor. Gentlemen, that will get you 1 conductor, 1 grounded conductor, neutral for the generator, 400 kcm. There's one little problem, though. What's the problem? I am paralleling at the generator. The problem is I'm paralleling at the generator. Because you parallel at the generator, guys, you are to use this method here. You take 600 kcm to 250.66. That will get you 1 aught. Then I have 5 sets of 1 aught conductors. So, so your conduit here, here's my conduit 1, conduit 2, conduit 3, 4, 5, and I'm going to show you guys only one conduit of them. And I'm going to show you a conductor coming to me. Here's one phase A, and here's my phase B, and let's do phase C coming with it. Here's my phase C, and I'm going to take my neutral, and here's my neutral conductor. So, and these guys will be these 3. The size with these will be 600 kcm, and the neutral, my neutral will be 1 aught. Can you guys see that? That's what I sized. I sized, and each one of these conduits, Adam, will be carrying the same thing. Can you guys? I don't want to draw that. Sit there and draw it. Can you imagine that each one of these 5 conduits will be carrying 4 conductors each? 3 of them are 600 kcm, and the neutral will be 1 aught. You have just sized a neutral for the generator. Any comments, guys? Any questions? The grounded conductor, Matt? Confused a little bit? So, a little bit. I do have 2 examples for you guys are going to do. So, hopefully, please do it. It will take you to the next level. It really does. So, that's the grounded conductor at the generator. Okay. So, we size the grounded conductor at the generator, guys. I'm going to go back and at the generator, the second thing I'm going to size, Adam, is 5. Can you guys see 5.0? 5.0 right here, that wire is called system bonding jumper. So let's go to 5.0. 5.0, gentlemen. Here you go, 5.0 right here. So here's my 5.0. I'm going to leave these conduits with me, carrying these conduits with me wherever I go here. 5.0. This is at the generator, so I need to focus on this one because I need to look at the generator. The way, do you guys remember that 6 conductors here? 600 kcm, 5 conductors? Everybody can see that? So I take 5 because I have 5 sets, multiplied by 6 conductor, 600 kcm, because each one of them is 600. Get you multiplied by 12.5% because they're more than 1100 kcm. That will get you 375 kcm. Unless you want to sell one of your arms or legs to buy a 375 custom design cable, you have to go to the next standard. 375 kcm, chapter 9, table 8, gets you 400 kcm. So that wire that tied the neutral to the ground inside the generator, like inside the transformer, it's called system bonding jumper. In this case, it will be a 400 kcm big wire, or it could be a cover bar. Remember these cover bars, guys, that we did? Cover bar. Any comments, guys, about the system bonding jumper at the generator? System bonding jumper at the generator. So that's your system bonding jumper at the generator. Let's go to okay, so now we're still carrying that. Now I'm going to go to this one here. Can you guys see that? This is called supply side bonding jumper at the generator. Supply side bonding jumper at the generator, 4.2. Okay, Adam, let's go directly to 4.2. Will you? 4.2. Gentlemen, 4.2 is identical. Identical. Can you guys see? Here's 4.2. It's a supply side bonding jumper, separately derived generator, or non-separately derived generator, 400 kcm. It's exactly as the system bonding jumper, and the load channel is identical. So these two are identical. Can you guys see that? So it will be 400 kcm. The supply side bonding jumper at the generator and the system bonding jumper at the generator are identical, exactly like the main bonding jumper and the supply side bonding jumper at the service. They are always identical. You need to do the calculation? No. So you just say identical and put the number for me. Any comments, guys? Any questions about the supply side bonding jumper at the generator? Adam? Makes sense? Yes? No? A little bit? Confusing? A lot of info? You guys are graduating now. We're going to send you to the good life, right? Okay, so like I said, you want to be a drafter and draw receptacle, guys, you can be the rest of it. I'll be more than happy to. A lot of people will be more than happy to do that for you. But this will take you to the next level. That's what we train you done. We need to be more than a drafter and laying out things as you're told. You will do this at the beginning, Matt, when you go work. You have to do what you're being told. But as you move on, you're going to run your own projects. So that will take you up to the next level. Okay, last thing I want to size for this generator. I want to go erase that one. So the last thing I want to size, guys, for this mystery generator is at the generator, Derek, my friend, you have to take a grounding electrode conductor. Exactly like we did the service. You take a wire from the ground bar in the generator, and you take it all the way to that ground bar outside. Remember that one attached to the wall? You just attach it to it. Now, what size is that copper wire or aluminum? That 3.1, that's the last thing. So we size the system bonding jumper, gentlemen. We size that neutral, and we size supply side bonding jumper. Last thing is 3.1. That's a wire goes from the generator all the way to the ground bar, or typically to the ground bar attached to the wall in the electrical room, where you bring one from the transformer, one from the switch gear, one from all the separate drive system come to that bar, one connection. Okay, let's go size that baby, 3.1, shall we? So let's go all the way to 3.1, gentlemen, 3.1. Here you go, right here. So your 3.1, I want to bring to your attention that we guys are doing it for the transformer, for the generator. 5 times 600 kcm. Why 600 kcm? Because remember, we're carrying 600 kcm, 5 of them. Give you 3,000. 3,000, take it to 250, that's 66. Get you, hey, don't go larger than 3 aught. No need. Unlike the system bonding jumper, where you start multiplying by 12.5%. Grounding electrode conductor, stop at 3 aught. Okay, so, gentlemen, you size it based on the separately derived conductor. If you parallel, you have to multiply, exactly like we did. You don't need to go larger than these two numbers, copper aluminum. And minimum, you need to tie to the water pipe or to the structure of the building. Minimum. That has to go to the water pipe or the structural. Typically, guys, in an electrical room like ours, inside the electrical room, our electrical room, which is going to be right in here, you will have that bus bar on the wall, and you tie all these grounding electrical conductors to it. Grounding electrical conductors to it. Any comments, guys? Any questions? Any comments? Any questions? So what you have witnessed is grounding and bonding, gentlemen, for multiple things. I'm going to summarize here for a second before I give you the homework that goes with that. So let me just zoom in a little bit to show you the whole big picture. I know you get lost. We get lost by not seeing the big picture, guys, here. Oops, that's too much zooming around. All right, there you go. That's good enough? Good enough, right here. Okay. Okay, so just to summarize, guys, what we have done, Adam, we started by going to the service, and we did grounding and bonding at the service. Grounding and the bonding at the service. Then number two, we went grounding and bonding on a sub-panel inside the same building. Number three, we did grounding and bonding at a panel in a different building. Number four, guys, we did grounding and bonding at a separately derived system transformer. And number five, we did grounding and bonding at a separately derived generator, So that's basically what grounding and bonding. Like I said, these are close to 13, 14 chapters, guys, in the book, in the SARS book, all grouped together in one sheet. And I like it to be one sheet, colored like this, guys, because it focuses all this information in it, instead of spending 16 hours with you. Any comments, guys? Any questions? Any comments? Any questions about what we've done? So these are the 5 things that we sized, Adam. The last thing, guys, is grounding electrode system, establishing the grounding electrode system, guys, here, and also establishing the grounding electrode system right at the separately derived system. This is called establishing the grounding electrode system. And also at the separately derived system, you have to tie at the separately derived system. Can you just see the ones that I highlighted? These are what you go tie your system to the ground. You go tie your system to the ground. Grounding the system, called grounding the system. Any comments, any questions? Grounding the system. This transformer, guys, you shall not be responsible for that one. This is utility XFR. This is the utility transformer. We don't mess with it. They ground it themselves, so we don't mess with that transformer, right? It sits there. We provide a conduit so they can put their wires coming to our termination box. So that's why I didn't talk about that one. It's already grounded. They ground it. They bring it grounded on the 480, but we don't mess with it. That's why you don't see these numbers here. I didn't say anything about them. They size them the same way, guys, but we don't mess with them. These are all what we get from them is 4 conductors, 3 phases and a neutral. And we create our grounding and bonding system inside our buildings. Any comments, guys? Any questions? Any comments? Any questions? The last thing I'm going to show you guys, this is called the demarcation point right here. From here up, electrical utility. From here up is owner. Can you guys see that? That's demarcation point. That's where the utility is responsible right here at the service point. From here up, that's responsibility of the utility. Maintaining the system, taking care of it. From the service point down, that's our responsibility, grounding and bonding and pulling wires and what's not. And we own and operate. You can see the service point is so important when it comes to the power system. And the service point is typically done right at the service CT cabinet or termination box. They bring their cable from one end, we bring our cable from the other end, and this is where we meet each other. This side is yours, this side is mine. This side is yours, this side is mine, in terms of conduit, wire, grounding or ungrounding. Any comments, gentlemen? Any questions? Comments, questions? Matt? So that's basically what grounding and bonding. We talked about this one before. Again, it's not new to you guys, but this is as intensive as we can get it to. I can't emphasize, when you establish the grounding electrode system here, you can have a rod, a pipe, a water pipe, a concrete encased electrode foundation. Any of these will qualify with some modification as a grounding electrode system to tie the system to the ground. And why do we do this? Nobody asked me, what the heck, why are we bothered with all this chat, other than I'm torturing you? The grounding and bonding, guys, is line one in the defense against shock hazard, and arc flash hazard and everything else. Your first line of defense against being electrocuted from any power system is your grounding and bonding. That's it. The reason, if you don't caring about killing people when you design a power system, everything that I said now is meaningless. It really is. So grounding and bonding, the main reason for grounding and bonding, safety of the people and the equipment, and not burning buildings, safety of the people, right? We don't burn electrical equipment, we don't burn buildings, facilitate the operation of the overcome protection devices, proper operation of the power system. When you have a neutral, bonded, and grounded, you the power system will be work efficient and work safely. Work efficient, properly, work properly, and work safely. So properly, the operation of the power system properly and safely. Any comments, any questions? Two homeworks that you guys are going to get with that one. Let me highlight these one for you. So let's go minimize this and go to our two homeworks. I can put this in the network where you guys can tie them together. Here's what I would like you to do. In order, if you do this one, guys, I'll get you a review of what I have done. Okay, homework number 11 and homework number 12. Let me walk you through these. There are two homeworks. I would like you guys to repeat all these calculations on the sheet. I prefer you not putting in the sheet in a separate sheet so you can keep a clean sheet for you, but I will put a PDF sheet on the network anyway. If you want to put all this stuff on the sheet, I'll get you a clean sheet. Here's what you need to do. Right at the service, Karen, instead of 4,000 amp, I would like you guys to do it one time for 3,000 and one time for 800. Right at the generator, I would like you guys to do a calculation for a generator of 500 kW and another calculation for 50 kW. Right at the separate building, I would like you guys to do the sub panel at 1200 amp and 400 amp, two separate calculations. Right at the separate building, 1600 amp, 3000 amp, 300 amp. The transformer, I would like you guys to do calculation for 45 kVA transformer one time, then 30 kVA transformer second time. The panel that goes with the 45 will be 120. The one that goes with the 30 will be 100 amp. So I want to highlight the red, the 11 and the rest. So when you guys do the calculation for homework 11, is that red? So you're going to take this and this and this and this, the first number, and this and this. Can I say this is 11, homework 11? And homework, which color should I use? Blue, red. Okay, the second one, this one underneath it, and this one underneath it, this one underneath it, and this one underneath it, this one, and this one. This will be homework number 12. Does that make sense? Which number goes with which? Am I making sense, Matt?
Yeah, is it 125 and 100 the bottom one?
Yes, 125 and 100. And you are, ladies and gentlemen, to do this calculation. Cool, do Monday. And please, Karen, I would like you guys to give it to me this time. Do it in a piece of paper, and this particular, and show it to me. Don't put it on the network or anything. Just show it to me on a piece of paper. All the calc. Cool, everybody's clear about this? So that's, we'll summarize grounding and bonding for, you take this one with you guys as you go. Critique it, give it to people who you work with, and critique it in any way, shape, or form. The rest of the day, gentlemen and ladies and gentlemen, we're going to finish our power. So by Friday, guys, I would like upper, lower, power, and roof, lightning and power printed, as well as scheduling. And I'll walk you guys through the schedules, the ones who are ready for scheduling. Everybody's good? Thank you. And sorry for the torture. Too much torture. Imagine doing 16 hours of this here. If you guys think this is nothing, huh?